introduction into percents. So last class we did the modeling, we did the estimating. Today we're going to be working more on this one, writing equivalent fractions, decimals, and percents. And we're going to do some explaining of the similarities and differences between them. Homework assignment is really actually only one page. 269, 270 is your stretch. Probably the easiest stretch we've done all year. So if you want to do the stretch today, this would be the one to do. Go ahead and open up in your modules to page 262. I know there may be some blanks before this. Not every class got to the same point last lesson. So we're just starting where the last class ended the best. Okay? So we're on page 262. In order to get us started on this one, I'm going to have you write down a couple of rules for how to do these. So you have enough space up here. Hopefully you write small. You should be able to get this in there. To turn decimal. Let's try that again. Decimal 2%. It's actually very easy. Move the decimal 2 to the right. And then I put the percent sign. It's literally all you got to do, guys. Some of the easiest math you are going to do is percent to decimal, decimal to percent. Why? It's because percent means what? Out of 100. Because percent means out of 100, if I'm turning it to a decimal to a percent, what I'm really saying is I'm going to take this number and I'm now, instead of writing it as a decimal, I'm going to make it out of 100. Well, we already know from, hopefully we all know, if I am moving decimals, I move it once for every zero that I'm multiplying it by, right? So if I'm turning it out of 100, how many zeros are there? How many zeros in 100, guys? Not a deep question. 2. That means I move it 2 places. So there's the how and the why. So the method I use, for example, on number 4, we're going to write each number as a percent. So all I'm doing is changing this. I'm moving it 2 places to the right, and I add the percent sign.
You should be writing this down.
Now, if I have empty spots, they get a 0. So if I move it twice and I have empty buckets, they get a 0. It's that easy. Is it possible to have a number bigger than 100 for a percent? Yes, it is. Okay? Now our second part is, how do I turn a percent to a decimal? Literally, you're just reversing it, guys. So move decimal 2 to the what? Left. 2 to the left, and drop the percent sign. So all I'm going to do is move it 2 to the left and get rid of it. If I do not see the decimal of my number, where in the percent, where is it? So for example, 47%, where's my decimal? I don't see one. At the end. It's always will be at the end. If I don't see it, it's at the end. Meaning, I put it here, I move it 2 to the left, and I drop the percent sign. Make sense? Okay, so you've got 10 additional problems to do on numbers 4 and 5. Go ahead and finish all of those. We're going to take a quick break at that point. We'll go over those before we introduce the next section. So I'll give you guys, it honestly should not take you long. We'll give you about 5 minutes to do this. Okay, guys, these should have been very easy. Wherever my decimal is, I just move it twice. If the 0 is before the number, do I have to write it? No. Would I be wrong if I did that? Technically, no. It just looks really bad, right? So you don't need that 0. Here, I just move it twice. Is it possible to have a decimal and a percent? Yeah. Here, I move it twice. Is it possible to have more than 100%? Yeah. So 152 is okay, right? Here, move it 2. Empty buckets always get a 0, whether there's 1 of them or 2 of them. Make sense? Yeah. Any questions on decimal to percent?
No.
I hope everybody understands. The reason we're moving it twice is percent is out of 100. So I'm multiplying it by 100 to figure out the percent. Now we're doing the opposite. Write each percent as a decimal. So now technically I'm dividing each number by 100 because I'm getting rid of the percent sign. So I start wherever my decimal is and I move it twice. Again, empty buckets, get a 0. Doesn't matter where my decimal is. I just start there. I move it twice, regardless of where it is. Now on this one, technically it's 8/10. Would it be wrong if I did 80/100? No? Does it really matter? Not really, but that one again looks better. But either one would be an acceptable answer. Here I've got the 0 in front of it, so I now end up with 2 zeros in front of the 5. So it's now 5/1000. Make sense? Any questions on either of these? So the biggest thing is, it's so easy, we're going through it fast, you're going to have to remember how you do it. Just remember, it all starts with percent being out of 100. Okay, now we're going to go a little more in depth. You can use different methods to write a fraction as a percent. If the denominator is a factor of 100, all you have to do is scale the fraction up to write it as a percent, because percent is out of 100. So if I get a denominator of 100, whatever's in my numerator is the percent. Okay? When the denominator is not a factor of 100, you just divide the numerator by the denominator to write the fraction as a decimal, which you can then write as a percent. So in other words, we're changing it to a decimal and then changing it to a percent, because is it difficult to do decimal to percent? No. Okay? Now, 3 of these are very easy to do as a percent. It says round your answer to the nearest tenth of a percent. So there is that piece of it if you need it. 3 of them should go easily to 100. C is the one that will not go easily to 100. So just as a quick reminder, how do I turn a fraction into a division problem to make it a decimal? Everybody remember the whole saying about the winner goes in the house? You guys may not have heard it. I think you did. Okay? So, when I look at a fraction like this, I look at it as a competition, because believe it or not, I'm a very competitive person. So to me, who would be the winner, the 3 or the 8? To me, the 3 is on top. That makes them the winner, right? So, to turn it into a division problem, the winner goes in the house, the loser is left out in the rain. Make sense? Guys, listen up. So, now, another way to remember this. If it's a fraction, should I get an answer bigger than 1? No. I know that a fraction, by definition, is less than 1. So, if you set it up wrong, you get an answer bigger than 1 that tells you you set it up wrong. Just start over and switch the numbers, guys. Make sense? Okay, there's only 4 problems. 3 of them should be very easy because they go to hundreds very quickly. So I'm going to give you guys 4 minutes to do these 4 problems. Go. Okay, number 4, part A, the easy one on this one, 5 times 20. But remember, if I do the denominator, I also have to multiply the numerator. That gives me 80 over 100. To change it into percent, I just drop the over 100 and put the percent sign. Okay? If you did it the fraction division, the 4 is the winner. He goes in the house, 5 is left out in the cold. Bring my decimal straight up. That's going 8 times. I'm at 0, so I just move my decimal twice. Empty buckets get a 0. Same answer. Either way you do it. How do I go from 10 to 100? Is it easy? Autumn? Good, times 10. So again, numerator and denominator get times 10. 30 over 100 makes it 30%. If you did it as the division piece, don't pull a Karina. Remember, the loser goes in, the winner goes in the house, not the loser. Oh, I'm sorry. Are we recording? So we bring in the decimal, it goes 3 times, subtract 30, now we're at 0. Move it twice, empty buckets get to 0. We still got the 30%. Numbers, part C, I showed you how to set it up. You had to finish out the division though. So my decimal comes straight up, that's going 3 times, subtract 24, gives me a 6, not at 0, so bring down another 0. That's going 7 times, subtract 56, gives me a 4, still not at 0, so we'll add another one, gives me a 5. I finally made it to 0, so now I'm at the point where I can move my decimal twice to change it into a percent, becomes 37 and 5/10%. Our last one, how do I go from 2 to 100? Times 50 gives me 150 over 100, or 150%. Questions on any of these?
No. First, that's better.
Don't ever do it wrong again. Sure. Guys, real quick. I need to do a quick pulse, see how we're doing on these. If we're going from decimal to percent, we're just moving twice to the right. How many are good with that? Thumb meter? Thumb meter, how are you good on that? Middles? Okay. So it looks like the most issues still with fraction to percent. Guys, this one really isn't that difficult. We've got space over here, so let's just add a note. If I can move this, there we go. So, fraction to percent. And I'm just going to go, I'll be honest, this one is kind of nice if you're able to do it. This one you can do every time. So this to me is kind of the better way to remember how to do these. So 1, do the division. And a special note for Karina, the loser goes outside.
Stop that! You go on the loser side.
The winner's in the house. Okay?
Okay, go inside.
And if you need it, the winner is the top, the loser is the bottom. Okay? 2, move decimal. 2 to the right. So I'll give you guys a moment to make sure you have that copied into your notes. But it's basically just combining what we just did with decimal to percent with what we've already taught you about how you turn a fraction into a decimal. Okay? If you didn't get it all, you can always watch the video later. I should have it posted before the end of the day. Okay, let's go to the next page. We're now on page 264. 263, like I said. Okay, our first one, we're going to label each mark. Guys, you shouldn't be talking right now. I am. On the number line with a fraction, decimal, and percent. So we're really doing all 3 of them. We need to have all 3. And our fraction needs to be in lowest terms. So we'll do the first one together. They gave us an example for 0. It's just a decimal 0 and a percent of 0%. So if it's 1/3, how do I turn that into a decimal? I divide it. So 1 is my winner. He goes in the house. 3 is the loser. He's on the outside. And I'm just going to divide. 3 doesn't go into 1. Bring my decimal up. It's going to go 3 times. Subtract 9 gives me a 1. Still not at 0. Does anybody notice a pattern? Is this going to go on forever? How do we annotate that? Autumn? Good. I put the bar. That's called bar notation. So if it's going to go forever, I write the number with the bar above it. So that means that 3 is going forever, correct? So to change the decimal to a percent, I know that 3 just keeps going, right? So I'm going to go 1, 2 to the right, and that becomes 33 and 3/10%. So if I round to the nearest third, we could make that a 3, or we could just use the bar notation showing it's going to go on forever. Does that make sense for everybody? So does everybody understand how you're now going to fill in these two blanks? No. So if it's 0 1/3, what would come next? 2/3. Okay. If I have a 6 with the bar above it, what's that telling me? It's going on forever, right? So how would I turn that into a percent? 66.6%. Because it's going on forever. I'm just moving my decimal 2 places to the right. Make sense, guys? Okay. Which part doesn't make sense? Oh, well, hold on, guys. Karina's having a really hard time. You just said nothing made sense.
No, I said everything made sense.
That was easy.
We'll go with your first answer, Karina. So Karina had a really hard time seeing if this is 0, this is 1, that means I broke it into 1, 2, 3 portions, right? So the first one would have been 1/3. The second one would have been 2/3. The third one would be 3/3, which equals. Is that making more sense for you? Good. Okay. Then once I have my fractions, it should be really easy to go to the decimal, right? Because we all know the top guy, the loser, goes in the house. The bottom stays on the outside. We just divide. Once I have a decimal, I'm just moving it 2 to the right. That's all you got to do, guys. So I'm giving you 2 more. You have B and C to do. You have to fill in all of the blanks. Remember, the fraction goes in lowest terms, so simplify it. And you might have some decimals. That's okay. In both the percent and in the decimal form, okay? We'll give you guys about 7 minutes to do the rest of this page. Go ahead and get started. You can check your answers as a table. Okay, a lot of people really struggled on this, and I'm still trying to fathom why. Because literally, guys, all you're doing for the fraction piece is going straight across. I mean, you can count the intervals, and you can see it goes 1, 2, 3, 4, 5, 6, 7, 8, correct? So this is how many of those intervals? 1. If it's a decimal, we just did a whole exercise. That was the one I got all the thumbs up on. You guys knew this. If I have a decimal, how do I turn it to a percent? Autumn? I move it twice to the right. And then I rewrite it with the percent sign. If they gave me the percent, how do I turn it to a decimal? Do the opposite. Start at the decimal, but now I go left, and I drop the percent sign. I continue to count. Instead of 1/8, this is now 2/8, which I can simplify because those can both be divided by 2 to give me 1/4. My next one, now how many spaces have I gone? Now how many have I gone? Guys, this isn't difficult. They gave me the percent. How do I go percent to decimal? They gave me the percent. How do I go percent to decimal? Move it 2 to the left. No, it doesn't keep going. 1/2. They didn't give me percent or decimal, so that's what I actually need to work out. 1's the winner. He goes in the house. 2's the loser. He's on the outside. 2 will not go into 1. I bring my decimal. It goes 5 times. Subtract 10. I'm at 0. I'm done. 5/10. I now have the decimal. How do I make it a percent? Move it 2 to the right. Empty buckets get a 0, 50%. I keep counting. This was 4, so my next one is 5. Can I simplify that? Nope. Here's my decimal, 2 to the right, 62 5/10%. Here's my decimal, move it twice, 75%. I'm now at 6, so that's 6 over 8. That one I can simplify, gives me 3/4. This one again, all they gave me was the fraction, so I'm going to have to go to turn it into a decimal. 7's the winner, he goes in the house. 8's my loser, he goes outside. Won't go into 7, goes into 76 times. 64 gives me a 6. Add on another 0 because I haven't repeated or gotten to a 0 yet. Goes into 67 times. Gives me 56, still not at 0, so I'll bring another one. That's going to go 5 times. Now I'm at 0, so I'm done. So what's my decimal? That's an 8. My apologies. So 875 thousandths. Once I have the decimal, percent is super easy. I'm just moving it twice. Guys, are you seeing these patterns? A lot of people really struggled on this. My next one, I cut it into, and they actually gave me the first one, so I know it's out of 10. So my next spot is going to be 2/10. That simplifies by 2, gives me 1/5. 3/10, can't simplify that. They've already done that one. This one is 5/10 or 1/2. Then I have 6/10 or 3/5. 7/10, 8/10 gives me 4/5. 9/10, can't simplify. So I've already finished the entire fraction line. 1/10. 1 divided by 10. That's not going to happen. So 0 there, 1 there. So 1/10. Move it twice, gives me 10%. They gave me the 2, 20%. You guys seeing patterns? That's what should have been the easiest one in the world. Questions on those? Are we feeling any better on these? Guys, this is your homework right here. Your homework is a whole chart like this where you're going to have to fill in the missing spots. Okay? So let's go to our next page. So on Saturday, Melanie won 3 out of 4 of her tennis matches at the Redstone tournament. On Sunday, she won 1 out of 4 of her matches at the Mesa tennis tournament. Each student summarized Melanie's record over the weekend. So you have Patrick, you have Laura, and you have Jonathan. You have 2 questions on this. Question number 1, what is wrong with Patrick's reasoning? So you need to look at it, tell me what he did wrong. And then what is the same about Laura and Jonathan's? And what is different? So there's 2 parts to that question. So talk as a table, look at what they said, see if you can figure out what did Patrick do wrong, what was wrong in his reasoning, what was similar about Laura and Jonathan, and what was different. I'll give you guys about 4 minutes. See? Now the key word here is actually one I didn't do, the reasoning, because was Patrick's math correct? Is 3/4 plus 1/4 1? Yeah, it is. Isn't 1 100%? Yes, so what's wrong with his reasoning? Did you figure it out, Legend? What about the denominators? He looked at individual matches. He didn't do the actual total, did he? Because how many should he have added these out of? 8. So his math was wrong because he didn't use the correct denominators. He used each individual day, not the total number of matches. Okay? So the bottom line, he had the wrong denominator. She played 8 matches, not 4. So he did a really weird thing where he kind of combined the part-to-part and made it into a part-to-whole ratio, but you can't do that, remember? If I'm doing additive reasoning, I need to be adding the individual parts, and the total matches was 8, not 4. Make sense to everybody? Okay? So what's the same about Laura and Jonathan then? So what did Laura and Jonathan, how did they look at this? What did they do the same? Why? What do you mean they did it right? Oh, let's do one on this side, yeah.
They both did additive reasoning.
Good, they both used additive reasoning. Though, what was different about them? Because we had to do the same man, what was different?
Jonathan lined his up.
What format did Jonathan use?
Ratio.
But how did he write his ratios?
He wrote them
Additive ratio.
What do we call that? What format is that?
Fractional.
Fractional form. How did Jonathan write them? It was a good guess, but it's got the fraction bar. It shouldn't have been too difficult. How did Jonathan write them? As ratios. Okay? So similarity, the same. They both looked at it. As part-to-whole ratios. And used additive reasoning. The difference Laura used fractional form. And Jonathan used ratio format. So really the way they wrote the numbers is really the only difference. Other than that, their reasoning was exactly the same. They both understood they were looking at part-to-whole ratios. They both understood I need to add the parts together out of the whole to figure out what the total was. And they both got the same answer of 4 matches out of 8. So what percentage was that? 50%, not 100%. Everybody understood? Everybody got all that? Okay, if you didn't get the rest of it written down, you can always check the video. We'll have it up probably next period. But right now, do we have time? Okay, so we probably don't have time for this one. This one, if you want to do it later, it's on page 267. They've given you a whole bunch of fractions, decimals, and percents. The goal is play the matching game. Put the correct decimal with the percent with the fraction. So I've seen how long it takes you guys to cut things. We don't have time for that today because apparently those kindergarten skills still need some additional work. So instead, let's go to this page. Everybody on this one? So we're on page 266. So you can interchange percents, fractions, and decimals. The chart shows some common equivalent fractions, decimals, and percent. You guys want to do something that's going to help you for the next 6 years in math?
Yes.
Memorize this chart. Honestly, guys, this is a great chart. They've broken them all down for you. You are going to be using all of these equivalencies for the next 6 years. That includes those of you that decide to go into advanced math and get all the way up into trigonometry and calculus. You're going to see these types of things consistently all the way through. Since we have a few minutes left, I want you guys as a table to talk about How are percents similar to decimals, and how are they different? And then number 2, how are percents similar to fractions, and how are percents different from fractions? Okay? And then our last one, how are percents similar to ratios, and how are they different? Okay? So you have 3 questions. So basically take about a minute for each of those to talk with your partners. See if you can get an answer for each of the 3. Go. Okay. I'm going to talk about it real quick. I'm not writing it, so if you want to write it, you can. What are the similarities between percent and decimal? They basically look identical. They're just 2 off from each other. There's a factor of 100. How are they different? The format is different. Percent sign has a percent. Decimal will always have the decimal in it. How are percent similar to fractions? They are both, they can both be written as a fraction because percent means out of 100. How are they different? With fractions, you can have any number. Percents always have a denominator of 100. And your third one, how are percents similar to ratios and how are they different? Kind of like with the fractions, percents are a ratio. The thing is, they're always out of 100. A ratio can be out of anything. Percents have to be out of 100. You can't simplify them, but the percents being, by definition, out of 100 makes it easy. Okay, go to the next page. It's 269. Here's your homework. Please pay attention and listen. And I would actually highly recommend tearing it out and marking your text. So what are you supposed to do? Label each mark on the number line with a fraction, decimal, and percent. So I need all 3. They've given you examples. They gave you at least 1 for each of the 3. Number 2, the table shows the portion of 6th graders at a school who have a particular number of siblings. Complete the table, there's our task, by representing each portion as a part to whole, a fraction, a decimal, and a percent. Okay? As a example, guys, please listen. I didn't tell anybody to get up. I didn't tell anybody to put anything away. I actually told you you should have a pencil out marking the text like I'm showing you. This is supposed to be helping you on your homework. So if you look at the last one gives you your whole. That whole should be used for every number in here. You can base all the rest of your ratios off that. Realize the ratio and fraction are identical, correct? So basically they've given you all of your fractions in simplest form, which should make it easier for the ratios. Your decimals, how are you going to do it? The winner goes in the house, the loser's outside. Make sure you do the division. Once you have the decimal, then it should be easy to go to the percent. If they gave you the percent, you can go easily to the decimal. But most of these, you're going to go from the fraction to the decimal, then move your decimal 2 to the right to find the percent. Is it okay to have a decimal in my answer? Yes. Okay. But it looks like all these numbers, 3/8 is going to get the furthest. You're going to have 3 decimal places on that one. So you'll have 1 decimal place when you get to your percent. Questions on your homework? Okay, this will all be due by next class, guys. Have a seat. I didn't tell anybody to get up.